NEC section 314.28 at dictates the requirements for size in pull boxes, junction boxes, and conduit bodies used in electrical installations. This section is crucial for ensuring adequate space for conductors to be pulled and spliced safely and effectively, especially when dealing with angle pulls or situations where conductors enter and exit the enclosure at different angles. Specifically, NEC section 314.28 at addresses the minimum dimensions required for boxes and conduit bodies containing conductor size 4 American wire gauge or larger that are pulled through or spliced within the enclosure. The primary goal of this requirement is to prevent excessive stress on conductors during installation and to provide sufficient working space for electricians. Let's delve into the specifics of NEC section 314.28 at to understand its implications for pull box sizing, especially in situations involving angle pulls. The core requirement of NEC section 314.28 at is that for angle pulls, or U-pulls, and splices, the distance between each raceway entry inside the box and the opposite wall of the box must not be less than 6 times the trade diameter of the largest raceway. This rule applies when conductors enter the box and make a bend of 90 degrees or more before exiting. The intention is to provide enough space for the conductors to bend smoothly without putting undue strain on the insulation or the conductor itself. To apply this rule effectively, firstly, identify the largest raceway entering the pull box. This is crucial because the calculation is based on the trade diameter of this largest raceway. For example, if you have multiple conduits entering the box with sizes ranging from 2 inches to 4 inches, the 4-inch conduit will be the determining factor in your calculation. Secondly, determine the minimum distance required between the raceway entry and the opposite wall. This is calculated by multiplying the trade diameter of the largest raceway by 6. So, if your largest raceway is a 4-inch conduit, the minimum distance would be 6 times 4 inches, which equals 24 inches. Thirdly, ensure that the dimensions of your pull box meet or exceed this minimum distance. The measurement should be taken from the point where the raceway enters the box to the opposite wall, following the path of the conductors. Now, let's consider a practical example to illustrate how NEC section 314.28 at is applied in a real-world scenario. Imagine you are installing a pull box where 4 500 cm conductors are being pulled through a 4-inch conduit. The conduit enters the box from the bottom and exits from the back, creating a 90-degree angle pull. According to NEC section 314.28 at the minimum distance between the point where the conduit enters the box and the opposite wall must be 6 times the trade diameter of the largest raceway, which in this case is the 4-inch conduit. Therefore, the minimum distance required is 6 times 4 inches, which equals 24 inches. If the pull box you are using is 24 inches wide, you might assume that it meets the requirement. However, you need to consider the internal dimensions and the space taken up by the conduit itself. If the conduit is positioned close to the edges of the box, the actual distance available for the conductors to bend might be less than 24 inches. To accurately determine if the pull box meets the NEC requirements, you need to calculate the available distance. Assuming the 4-inch conduit is placed symmetrically within the 24-inch wide box, you would subtract the width of the conduit from both sides and then divide the remaining space by 2. This calculation would look like this distance equals 24 inches minus 2 times 4 inches divided by 2, which equals 8 inches. In this scenario, the available distance of 8 inches is significantly less than the required 24 inches. Therefore, a 24-inch wide pull box would not meet the NEC requirements for this particular installation. To comply with NEC section 314.28 at you would need to select a larger pull box. A 36-inch wide pull box would provide sufficient space to meet the 24-inch minimum distance requirement. The calculation for the 36-inch box would be distance equals 36 inches minus 2 times 4 inches divided by 2, which equals 14 inches. In this case, the available distance of 14 inches is still not enough to meet the 24-inch requirement, therefore a larger sized box is needed. By using a larger pull box, you ensure that the conductors have ample space to bend without being subjected to excessive stress. This not only makes the installation safer but also extends the lifespan of the conductors by preventing damage to the insulation. It's important to note that NEC section 314.28 at WO is not the only factor to consider when sizing pull boxes. Other factors, such as the number of conductors, the size of the conductors, and the presence of splices, can also impact the required box size. NEC section 314.16 provides guidelines for calculating box fill, which takes these additional factors into account. Box fill calculations ensure that the pull box is not overcrowded, which can lead to overheating and potential safety hazards. In addition to NEC section 314.28 at WO and 314.16, it's essential to consider any local amendments or interpretations of the NEC that may be in effect in your jurisdiction. Local codes can sometimes be more stringent than the NEC, so it's always best to consult with your local electrical inspector to ensure compliance with all applicable regulations. When working with pull boxes and conductor installations, always prioritize safety. Firstly, to energize the circuit before working on any electrical components. This prevents the risk of electric shock and ensures a safe working environment. Secondly, use appropriate personal protective equipment, including gloves, safety glasses, and insulated tools. This will further minimize the risk of injury. Thirdly, follow proper wiring practices and ensure that all connections are secure and properly insulated. This will prevent short circuits and other electrical hazards. In conclusion, NEC section 314.28 at WO plays a critical role in ensuring the safety and reliability of electrical installations. By understanding the requirements of this section and applying them correctly, you can ensure that pull boxes are properly sized to accommodate conductors and prevent stress on the insulation. Always remember to consider other factors such as box fill and local codes, and to prioritize safety when working with electrical components. By following these guidelines, you can create electrical installations that are both safe and compliant with the NEC.